Yeah, all right. So we're first of all, happy Monday to you guys. Hopefully had a good weekend. We are jamming with this problem here, which I think we finished. Is that true or not true? What do you guys say?
If finishing means graphing it, then yes.
Okay, but did we find the middle point though between the two?
We got really close.
Yeah, okay. Let me.
I think we can find it if we use the calc and then intersect.
Uh-huh. That's what I'm looking for.
Which looks like, yeah, I think that's it.
Huh. 1 second here. I thought we did find the intersection point here, but if not, I'm going to go back to it here. That is so weird. Okay. My calculator doesn't want to work. So let me start it up again. Let's see if it works now. Go over to this side. Ding, ding, ding. Oh yeah, way better now. Okay, boom. Okay. So we have to put in one of two ways to put it in here. So let me just catch you guys up on where we were before here. So I have this, I have a y is equal to this right here. And then also have a y inside the equation. Good there? So one way you can do it, you can graph two equations if you like, but it's a lot easier to set it equal to 0. And so what we do is we solve for y, or we plug in the y value. So we're going to plug in this y value right into here. So negative 4 e to the negative x plus 3x plus 8 is equal to 0. And this is important too, because your calculator can calculate zeros pretty well.
How do you solve this? It's just equal to 0.
Have it equal to 0. So now let's go graph it. So we're going to see if you guys can you guys put this into your graph or into your calculator. Please, you are on the list.
Negative x.
Negative, yeah, e to the negative x. And we could probably do it two different ways even. That's fine too. Let's go here. So I got negative, and on your calculator, careful here. This guy here is your negative button. That is your subtract button. One's a negation, one's a operation. So we want negative here. Negative 4. The E little button is right up next to ln. Right here. So you have to hit the second function. And it opens up a little parenthesis all the time. So negative x would be negative here, x over here, and close off that parenthesis because that closes off the exponent. Okay, very good so far. Okay, and then you tell me if you are stuck with something, okay? So plus 3x plus 8 equals, and enter. There it is. I got my function. I got my function as a single equation. Good there? So now let's go on to graphing it, and let's at least get a good graph of it here. So let's go to graph. Let's see, we got, this is the standard graph, negative 10 to 10. Oh, Charlie, you need a calculator. Okay, it looks like it passes right there. So the question is, what is that 0 there that it passes through? Let's go for it here. So what we want to do is, let me just check something. Yeah, of course, there it is. Under calculate, so second function, and above the trace button, there's called calc. Love that. And we're going to go to 0 right over here. Got number 2. Number 2 is called a 0. We're going to find our 0 for our equation. Charlie, real quick here, just make sure you're caught up here. I got y equals this guy here. Got that in already? Okay. Let you catch up here. Tell me when you're done, so we're all together. Cool. Okay, and then we have, then we did the graph for it, went like this. I see something right there. So we're gonna go to second function of the trace button called calc, and we're gonna go to number 2, which is 0. And it says left bound. Are you okay with left bound? So what we wanna do is we wanna be on the left side of the 0. So you're gonna use your arrow keys left and right, go to the left, and you wanna be in the left-hand side. Above or below doesn't matter, as long as you're before it actually hits the 0 as you're tracing. Click on enter, and it's going to say for a right bound. So then what you do is you go past the 0. It doesn't matter how far past the 0, as long as you don't have another 0 inside there. We're good? As long as it kind of wobble back and forth. Dylan, question?
Did you change your X minimum and maximum value?
I don't know. Let's see what I have right here. I'm at -10 to 10. Dylan, mine is like the standard window, -10 to 10.
Okay.
By ones, -10 to 10 by ones. So calc button, number 2, which is the 0 button. Left bound has to be on the left-hand side of the 0. So as you're tracing with your left arrow key, click enter. You go past the 0, click enter, and you should see this little, these little funny these little triangles right over here. See those triangles on your calculator? All it means is your calculator is going to look just in this area here only, and no other area.
So we're doing the intersect, right?
No, we're doing the 0 button.
Oh, I see.
And then all we do is it says guess. So just kind of get a little close to that little 0 there, and click guess. Okay, and talk to me, see if you guys got a -0.49007 something. Yes, okay, I got a 1. Got a yes for Landon. Any others? Yes, Tristan, Dylan, how are you guys doing there?
I was still trying to figure out the whole graph thing.
Okay.
So I don't know what to do after.
Sure, no problem. Guys, this is for you guys to leave out of here knowing exactly what you're doing, not for me to. Okay. I think you press this E as opposed to pressing this E over here. So let's go back. So yeah, so now the -x. Wow. And then move out of the exponents. And now let's add 3x. That's 8. And voila. Okay, so let's catch up where you should be. So let's do calc. On 0. And the left down, so a little bit left of it. A little more, just a little more. Yeah, that's fine. Click enter. Just jump to the other side of the 0. Perfect. Click enter again.
Oh, okay.
And then guess we just go back on your. Perfect. Yeah. And then, sure. Yes. Okay. I got thumbs up. Maddie, thumbs up on that one. Owen, thumbs up on it. Yeah. Cool. Okay. So class, just real quick, just to tell you, yeah, with technology, it's awesome because we can solve stuff that we could never have done before, or else it would make it humongously difficult. Now, we talked about last time that we were stuck because notice this little x right here is in the exponent of e. Then you got another x, which is just a regular x inside the algebraic equation. That's what makes it stuck. We can't solve one or the other. We need things to be in the exponents completely. Then we can use logs, or we just use algebra, but we can't do both. So that's why this is kind of very important to be able to solve here. So find an accurate solution to 2 decimal places on this guy. So I'm looking for what? Negative 0.49. Are we good? Bam, and done. Negative 0.49 is what equals to x. And we did it by technology. And then the only other thing that we got to check as well on this here, going back, no one mentioned it yet, is just to zoom out, just to sort of see maybe, possibly, maybe this thing hits back afterwards here. So maybe you can click zoom right here. And number 3 says zoom out. So it could be that negative 10 to 10 was not a good window, or it comes back on itself here. So click on that. And our little cursor is going to be at different positions here. I like it to be at 0, 0. So this is zoom feature. Number 3 is to zoom out. And here's my graph. Whee! And yeah, now I'm zoomed out to like negative 40 already. So I'm pretty sure this thing is not going to hit again. Okay, are we good there? Yeah. Okay, so real quick here, let me go through the stuff we've done before. So substitution method number 1 was you take the linear function and you plug it into the other one, solve for one, plug it back in, and you get the other value. We good? So this is when you have 2 linear functions, and it doesn't matter which one you use, except you want the one that does not give you fractions. We're good? Jumping to this one, like, whoa, now I have a linear one and a non-linear one. I want to solve for the linear one first, because we call it a one-to-one correspondence between values. Plug that guy into your non-linear function and solve no matter which way you need to solve, plug it back in to get the other one. 2 non-linear values, that's kind of nice. They're both equal to y, but yet at the same time, at that point, it's setting them equal to each other and trying to solve. And then ones you can't even find using algebra techniques, which is technology here. So let's jam to oh boy, solving stuff now. So don't expect you to write everything down over there, but maybe the important parts. So I have a small food restaurant. We are going to invest $5,000 to purchase a new food item. We're going to sell for $3.49 each. So we purchased the rights to actually produce it for $5,000. And then we find out in order to produce it, it takes $2.16. So I guess how many items do we need to sell to break even? How many items must be sold to make a profit of $8,500 here? So write down all the important stuff if you need to. We're going to make a $5,000 purchase. We just want to make sure that we get our money's worth out of this. And so this whole concept is the fact that we have 2 things happening at the same time. We're good? So we're going to make some functions here. Let's begin to make some functions here. And so we're going to do a little bit of the lazy way here, okay? So instead of saying f of x, right? What we do off to the side is we have c is going to give us cost. And c is not a variable. C is the cost function. R, instead of putting r of x, I'll do it the lazy way, just write r. R is your revenue function. And what in the heck is called the break-even point? It is when C is equal to R. kind of like two different equations though, right? One is for the cost. So let's go now down the list here. What does cost function entail? Cost function is usually, in case, cost per item. And it's times X then, and it's plus initial cost. And it goes by different names. Sometimes called manufacturing cost. Thank you. Please ask me here. So you guys, this is cost per item to produce. Sometimes called production cost. Sometimes called manufacturing cost. Then you have initial cost. What did you do to invest it here? Sometimes called, I think it's called constant cost, or what's the other one here? Let's say we even static cost, I guess we can do it like that. So it doesn't, no matter how many you make items, that one doesn't change. Okay, good there. And revenue is just revenue. R is equal to price of item multiplied by X. All right, and the sun is beginning to show. All right, so you guys talk to me here. Here it is. Give me the cost function. Talk to me, yourselves. What's the cost function going to be?
Be 3.49x plus 2.16. Or the split. It's different way. Yeah, I
Say again?
I understood the difference of 3.49 and 3.16. That's how much you're making on each item, and then I divided 5,000 by that.
That is so cool.
Yeah.
Absolutely. That is a.
I feel like that's the way it's supposed to be done, but we're trying to make it into a function. Is that the
Sure, yeah.
Okay. Is it's like really easy to do it in your like?
I just added the, if you want to make it $8,500 in revenue, I added the initial 5,000 that you need to sell to break even, and then you have to sell more to get to $8,500 in revenue.
So we just creating that equation now?
Yeah.
Then it would be 3.49x minus 2.1.
Oh yeah. Let's see. So cost function. I'm going to go like this here. So in order to produce it, we're going to be selling it for this much. So that would be part of our revenue function. Right. So how about 2.16x? And so our cost in here, cost is that much right there. Right? And Abe, we'll see how the subtraction of those two are going to happen in just a second here. Cool. I got a revenue function. Now, since we're selling it for $3.49, there's that little guy there. So two functions are set in place. All right, break-even point happens right here. So the two functions equal to each other. So if, right, I want to write the revenue function first, cost function on this side, that's fine. But notice what Abe was saying is that when we start solving this, you guys did algebra in your head. That's awesome. There's the two functions set equal to each other. And so, yes, the difference of how much it costs to make one and how much we're going to sell it for is this much right here. That's so cool, because look at that. In an algebra sense, our movement across the equal sign actually makes sense, right? And the problem itself. Talk to me, anyone. 349 minus 216. 1.33, perfect.
Oh, then you divide them.
And then you're dividing this guy into the other one here. And voila, what do we get about?
It's about 3.759.
379.
Yeah, 5.
59.
Yeah, 375.
Oh, gotcha. We're in the thousands here. 3759.
That's like this.
No, that should be about right because 1.33. So we need to sell 3,759 items to be about break even here. Okay, and then the other one here, profit. Profit equation, here it is. There's a third one here. Profit is revenue minus the cost itself. No one got it. Owen, jamming 3.49, subtracting off this right here, 2.16x plus 5,000. There's our equation, right? Because part of this is actually to build your equations out, right? And if you were to own a corporation, be part of it here, right? You'll build each one of these equations out. One for the cost function, one for how about employee retirement benefits? There's going to be a function for that. We good? Then you have insurance on the company. Then if you have vehicles, right? Then you have the lease on the vehicles. Then you have the insurance on the vehicles. Then you have paying the drivers, right? All these things sort of add up. So by the time you're done, you have numerous equations on your hands that you're dealing with.
I feel like my dad does none of this.
All right. Hey. And this would be a, this would be a, like a Nike corporation. This would be like Target. We get, that's what we're kind of looking at. Okay, let's jam. Let's see. We want to make $8,500 in profit. And notice I can distribute this out now. And Owen, he did this. And this is the interesting thing is you can do this algebraically. Owen, he did it more like a pre-algebra problem, right? Because he said, okay. Say again?
It was a lot faster.
A lot faster, yeah. Because you're just moving things around in your head. And I think that's kind of what happens. This is like the formal way of seeing it. But normally what happens, if you can move just numbers around really quick. So I got 13,500. The difference between my revenue and cost of per item is still 133. Divide 13,500 by 133 makes.
10,150. Roughly.
Is that what you guys, is that what you got the pre-algebra way, Owen?
Yes.
Awesome, okay. That's cool, okay. So, Camille, we are just looking at 7.1 and we're looking at the application questions, 7.1. Okay, final answer right there. A little bit over 10,000 units sold in order to break even on that. Question, Tristan?
So like on a test, if we had a question like this, we wouldn't have to do like all the C and R. We could just.
Yeah, you could, yeah, I would just say solve it here. If you can do some of that in your head, at least show your work, at least show your thinking though, in your head. Okay, let's jam, boom, 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 boom. Okay, so a business application jam to a geometry application. Again, thinking about two formulas that make this happen. I need to find the dimensions of the rectangle, meaning the specific conditions here. So I know perimeter is 280, the width is 70. The width is 20 centimeters less than the length. Ooh, so there's an interaction between all these different formulas. All right, let you write it down. We'll do it together here, but think of all the formulas that go into a rectangle. It looks like we're trying to figure out length of sides and perimeter. So I think we should know the perimeter formula. All yours. Done. That's so cool. Cool, I'm gonna do this here. So first things first, I'm gonna draw this out. Some people can do it in their heads right away. That's awesome too. And so the perimeter, and usually for perimeter, we kind of write it inside here. So P is equal to 280. Let's see, the width is 20 less than the length. So I got a relationship there.
L minus 20, something like that.
I think I can even do like this right here. So W
It's L.
width is, because that's equal sign. And then, yeah, 20 less than, and whenever you say less than, it always works backwards. It's 20 subtract from whatever here. So that means the only thing that's not qualified yet is just L, right? So then we have L over here. Boom, 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 connection between the two. So I have perimeter formula, that, and the perimeter formula from geometry. This one we'll need on the homework here. It's this little guy right here. So P is equal to 2L plus 2W. And then I'll ask how some people solved it in their head real quick here. So I'm gonna go with 280 plugged in for P. And then let's see, as I get to L, I still leave L as L. As I get to W, can I plug something in for W?
Almost 20.
Cool. And yours to solve, go for it. Let's see, multiplying in gets me that. 4L minus 40. Divided by 4. $80 for length. Then my little understanding of what L is. And I got myself 64 for width. Are we good? All right. It's funny. Okay. Better. And centimeters. So I got this here. So L is equal to 80 centimeters. Width is 60 centimeters. And I'm done. Talk to me. Those that did it faster than me. How'd you guys think about it?
I mean, I've seen problems like this before. I basically just subtracted or added 20, well, 220, so I added 40. So I went straight to that last step that you did and just did 320 divided by 4 to get the length.
Mm-hmm.
And
Like
then,
right here, right?
yeah, so I started there.
Uh-huh. Because you know the length dimension here. So if you take this and you add a double of this one right here, that's going to give you the whole entire thing plus the additions, right? Added in. That's cool.
I just divided it by 4, then took 10 away from 2 of the units and added it to the other 2.
That also works.
So hold on. This divided by 4 gets you 70, and
Yeah, and I took, and that's basically 4 70s, and I took 10 away from 2 of the 70s and added it to the other 2 70s.
Because
gotcha. Uh-huh,
It would
yeah,
end
yeah.
up with 60, 60.
Absolutely. So 10 divided by 2 give you 140, right? So it breaks up into two 70s. And then we go up by 1, gets you 60s and 60s. Or the other way around, right? 80s and 80s, right? Because that'll make a difference of 20 between the two. That is so cool. Good job. Good job in thinking through. Okay, a little more complicated. Let's see if we can guess at this one. Sure, sure. And I forget to write these out. So what are the dimensions of a rectangular tract of land if the perimeter is 40 kilometers, area is 96 square kilometers? Do, 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 do.
It's just like factoring what multiplies to equal, what adds to equal.
And the numbers are nice. All right, anybody got them yet? Awesome. We'll do the algebra way as we break it down into pieces here. So dimensions of a rectangular tract of land, I got this right here. And I have two things here. I got P is equal to 40, A is equal to 96 at the same time. This true is, you got two things that are perimeter formula, and you have an area formula. And I got two different dimensions. Two different equations here. So I got 40 over here, L plus 2W. This one will be 96. Now it's L times W. All yours. Anybody want to try to solve it here? Since I have the algebra questions or equations in front. Which way would you go? Yeah, notice these things are multiplying each other, right? So I'm thinking probably solve for this one first, because that's a linear relationship between the two here. So I'm gonna go, doesn't really matter for L or for W, but I'm gonna solve for W. Divide by 2, divide by 2 over here. And that 2 is gonna divide both of these guys here. So solve for one, plug into the other, solve for the other. 96 is equal to L times 20 minus L. L minus L squared, is that right? Oh man, I think I have factoring on my hands. So let's see, I think I'm gonna have to move everything over. This will be L squared minus 20L plus 96 equals 0. Will that work? Tell me if you guys agree there algebraically. So I need two numbers, multiply to 96, add to negative 20. By me. If that's the case, then I have L is equal to, or W, sorry, W is equal to 20 minus L. So W, 20 minus 8 makes 12. But then W is 20 minus 12 makes 8. And yes, they are going to repeat themselves. And this one, because the W and the L are really in a sense not specified, they could be interchanged. So in this case, L we'll just choose the length to be the longer one here. So I got 12 kilometers, the width be 8 kilometers. Okay, talk to me. Those that did it quickly, what'd you guys do?
Found a math class was 96 and it's 12.
Yeah, that was the first one. I got.
Okay, so factoring down 98 into 8 and 12.
Or 96, yeah.
Sorry, 96, sorry. 96.
Multiplied by 2 math and others.
4. Add those up. Does it give you 40 question mark? It does. Da, 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 and done. Easy enough. Okay. Let's do this here. Let's go a little bit. I think we can do that, yeah. Okay. Since people are getting answers before me, let's jam to some theoretical stuff here then. So first things first is this right here. This is the easy one. I have an equation of a line. It's x squared. Six. And if we get through this one, we'll set up another one for you here. So don't have to write down all of it. Can you give me an equation of a line who's going to intersect x squared? Then it intersects at 1 point. Another equation that intersects at 2 points. And another equation that intersects at 3 points. Yeah, of course, there's more than one answer here. So can you set up the equation? Let's talk about it as well. So this is talk as a class. What do you guys see? And we'll start off on this side of the room. So we'll kind of work our way up. Landon, talk to me. What do you see? What are you thinking?
So for 2 points, couldn't you just do like y equals 1? And then you just go straight across through 2 points.
If you go y equals 1, horizontal lines are so easy, right? Because you know exactly where they're going to land. Boom. Okay, that's a good equation for, so for A, I get y is equal to 1. Dylan, all yours for 1 point.
Couldn't you just do or y equals 0 and then x equals 1?
Again, super easy stuff. It hits it right there. Is that right? Y equals 0. And horizontal lines are awesome like that. And Tristan, all yours. I want it to hit at no spot whatsoever. Just go a little bit lower, huh? Y equals -1. Perfecto. Then we're over here. And that's super easy. And then we go to Owen. We say, Owen, I want this thing to hit at, let's go backwards just for the fun of it. Can't be a horizontal line. That's the other condition. Not a horizontal line. And it hits at, one spot for Owen, just to kind of get him going.
It's in one spot. Let's see.
Camille, has to hit at 2 spots. Charlie has to hit at no spots. Okay, no points whatsoever.
You can,
And talk to me what you're thinking. I'm more interested in what you guys are thinking in your mind, okay? So, Owen, good.
well, it's
Talk to me.
a parabola, so if I shift it to the left or the right, it's
Uh-huh.
only gonna hit once. If I shift it up or down, they'll never touch. So I need to shift it to the left or the right by any amount. It doesn't really matter.
And which one are you doing? 1 point?
Me, yeah, just one.
Okay. Yeah, so what kind of line though? It has to be a line, can be a
Yeah,
horizontal.
Yeah, I think you have to put parentheses.
Sure, go
Right,
ahead.
y equals x squared minus 1.
Ah, gotcha. So we're not moving the parabola at all. We're just getting a line that would actually hit it at one spot.
Is it a parabola? So it can't be another parabola?
No, not another parabola, just another line. Give me an equation of a line.
And it can't be horizontal,
Can be horizontal.
can it be vertical?
No, can't be vertical either.
Because that's undefined.
Just make a diagonal line.
It's gonna be
Yeah,
some
but
kind
a
of
diagonal
diagonal
line
line,
will-
of some kind, yeah.
Will always hit.
You could just follow slope formula.
What's different in this one than the other one that we're trying to find?
Can be a horizontal line, because those are too easy, and it can't be a vertical line either. We'll come back, because that's the tough, I gave Owen the tough one here. Camille, can you give me one that intersects at, what was yours, 0 spots? Yours 0, okay, 2 spots.
I don't do graphs. No.
Gotcha, I'm thinking like this, I'm thinking for the 2 spots, Camille, easy one, you actually connect the points, right? You can actually start 2 points here. I'm gonna connect 1 point here.
That's what I was gonna say.
Y equals X would be just fine. So if you go 0, 0, 1, 1, because 1 squared is still 1, right? So we have this little line here that's going to cross just like that. It has a slope of 1. The y equals here. So in this case, there's my y equals 1. Perfect. Good job. So I got this one. Boom. Oh, no, hold on. The other way. 2 points. 2 points is over here. Da, 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 da. Okay, Charlie or Owen, all yours. Which one do you guys want to do? Charlie, did you get one?
Maybe like y minus x equals 4 or something. Doesn't that just like, it doesn't go anywhere near the parabola?
I think what you meant to say is x minus 4, right? X minus 4.
Right.
Yeah, and then if you go all the way down here, you have the same slope still, but then you're all the way down here to begin with. So that means you're just going to cross here, here, and that's it. It doesn't cross anywhere other time else. Sweet. Dun, da, da, dun, da, da, da. Okay, so I got that one. Oh, and that's C. 1 second, moving things around, moving things around. That's awesome. Okay, making your brains work on a Monday?
Yeah, 1 to the 1 point.
Yeah, go ahead, good.
If you do y equals 0.5x, then it would still hit 0, 0, and it would hit 1.5 or 0.51, then it wouldn't hit anything.
Okay, so we're hitting this point here, is that right?
Yeah, then it's y equals 0.5x, then it would just cross through the 0, 0. That's the other point.
Ooh.
That's because you're thinking of just the points like.
Yeah, that's awesome.
But there's a curve between
It
those.
wouldn't be 1.
Yeah, so let's
That's-
see.
It would be on the parabola.
So the parabola comes down like this. Let's kind of zoom in, kind of, sort of, right? And so if you're at 0.5, this guy will still curve under. And so let's say 1 is all the way out here, right? It'll still hit here and then hit here and then keep on going. It still is going to hit before
If you have a
because you're
curved line,
curving that side.
If you just do the reverse of the parabola, which is y equals negative x squared, and then it would just be upside down and it's still only.
Yeah, they said it has to be a straight line.
It just can't be horizontal.
I already used.
Yeah, the equation, yeah.
Yeah, I would have
The
the
equation of a
idea
line. It has to be a line. So it has to be a straight line.
And is there anything?
There is no way, if you have a curved line and a straight line, anytime the straight line hits the curved line, it's on the other side of the curve. And since it's curving, it can't keep going without hitting it.
Yeah, that's what you just said.
Yes,
right?
so there's no solution.
No solution, like I say?
Yeah, there's no
I'll say this, there's no solution at 0, 0, because we have a curve that's adding up, but I
There's
think there are
probably-
solutions others.
There's probably a solution where it like just touches,
Uh-huh,
but I can't like just visually tell you what that graph would be. I'll
Gotcha.
find that out.
no problem, Dylan.
Can you just pick an asymptote in the,
How do you make an asymptote?
do a fraction?
Talk to me some more,
No, I don't remember exactly how we could do an asymptote in 0 and then have it just like on the left side, it would only, and just have it like curve up, it would only hit at once.
I don't know, guys. Go back to here. Let's see, I'm gonna go x squared on here, right? Boom.
Could you do something like y equals 0.5x minus 4? So it starts down low, but then it keeps going over at the same rate as the square speed, so that it never hit it?
Yeah, but we needed to hit it once.
Yeah, I know, that would cross it, it would come up through the beginning, but then
Uh-huh.
if it goes over at the same rate as the square does.
Oh, that's true.
Yeah, so it's actually about rate right here, huh? So let's say it's trying to hit, yeah, we're trying to hit just one piece right there, right? So it has to be, we call it a tangent line or secant line. That's technically what we call it here. So 1, 1, let's see if we can finish before class here. I want to hit it right at 1, 1. That's what I want. Notice that after this little point right here, it's curving faster than 1, isn't it? Right? So then we need to get a line that's going to go just like this. It's going to come in, just touch right there and kind of keep on going this way. And so is there a way to do that?
Well, I mean, if you have, you could also, couldn't you do it so that it crosses and goes inside the parabola as long as this, like, the slope of the line that's inside is less than the parabola is gonna keep going out. So
But once you go inside the parabola, you're going to hit the other side somewhere along the loop, right? Because the parabola's going to turn.
does it, well, because it's not gonna turn this way.
Oh, over here, like right over here?
Yeah, it's.
Okay, yeah. So Owen's saying, okay, let's go further out, right? Let's go like out to here. Let's say this is like 4, 16, right? There's a square point right here. So then as long as we have a line that goes like this, very, very steep, right?
Yeah, it's
And it
not
go boom,
horizontal.
and it's gonna go like that.
super steep. That parabola is gonna climb outward faster than your line is.
Uh-huh, we're good there? Will that work? It could be any point whatsoever, but we'll just choose 416 for purposes. So it can't be, the slope has to be like huge. Let's say slope is like 100 or 1,000, we good? We just need to figure out what that B value is compared with the A value.
Yeah.
And so, but we wanted to hit this point here called 416 though, right? So all we do is we go like this, 16 goes in for here. Okay, I'm exaggerating. Okay, let's go 10.
No, 1,000 works.
1,000 works better, okay. Just to make sure that Owen got it here. So we got 4, and then we just need to figure out what the B value is. So you guys help me out. 16 divided by 4,000.
So. Wait,
No, what is that?
no, that's not what you do. You just do 4,000 minus 16. Or you minus 4,000, sorry, 16 minus 4,000 will give you B.
16.
Minus 4,000.
Which is negative 3,984.
So that's your.
Oh, yes, dividing. Sorry, I was dividing by, yeah. Uh-huh.
So your y slope is negative.
Negative 3,000, what? 984.
84.
So we got it. Here it is. Y equals 1,000x minus 3,984. So that means all the way down there, right?
Negative
They'll connect.
3,984.
Uh-huh.
But
And
it's
if-
got such a gradual slope of the parabola, it never hits it.
Uh-huh. Perfecto. We got it. Okay. Was that a fun Monday exercise for your brain? Did that work? Yeah, okay. I think I gave Owen like a stretch to think through, man. Finally, like, wow. This the first time in this class you had to think through or something, or no?
I've had two before. but
Okay.
That was probably the hardest problem we had.
Okay. I figured we could just jump to some kind of theoretical problem. That'd be fine. Okay. Cool. Okay, guys, enjoy the rest of your day. I'll see you guys on Wednesday, hopefully with some tests given back to you guys.
Can we do 3.1 now?